Our solar system consists of many planetary objects, like the Earth and other planets that orbit the Sun, the Moon, and moons from other planets, asteroids, and other smaller objects. But the center of the solar system is the Sun. It is so large that it accounts for over 90% of the total mass of the solar system. It is made up of gases like hydrogen and helium in very large proportions, and other gases like oxygen in smaller proportions. These gases are constantly reacting through fission and fusion to produce a very large amount of energy. This energy is emitted through the solar system as a wave. But since the solar system is filled with space, which is a vacuum, how does this energy travel in a vacuum? In this lesson, we shall look at a special form of waves called electromagnetic waves. At the end of this lesson, you should be able to define what is an electromagnetic wave and the mode of propagation. The region around a magnet, where any magnetic material will experience a force, is called a magnetic field. Also, the region around an electric charge, where other charges experience a force, is called an electric field. When these two fields vibrate perpendicularly to one another, their combined vibrations result in a wave that also travels perpendicular to their vibration. This is what is called an electromagnetic wave. Looking at this diagram closely, you will see that the electric field is vibrating vertically. Looking at the magnetic field, you see it vibrating sideways to and fro. If we draw the angle between them, you will notice it makes an angle of 90 degrees. This is why we said they are perpendicular to each other. Now let us compare their direction of vibration to the direction of the wave. As you can see, the wave is moving horizontally. Looking at the angle the electric field makes with the direction of the wave, you will notice this makes an angle of 90 degrees. Doing the same for the magnetic field, as you can see, it is also 90 degrees. From our quest on wave motion, we said in our lesson on mechanical waves that a wave where the vibration of the particles is perpendicular to the direction of the wave is called a transverse wave. So electromagnetic waves are transverse waves. Electromagnetic waves can travel in a vacuum, like from the sun to the earth through space, and can also travel through a material medium, like air, water, and glass. They also travel at different speeds or velocities in a vacuum, different from other material media. But in a vacuum or space, electromagnetic waves travel at the speed of light. Just like in other waves, electromagnetic waves can be reflected, refracted, diffracted, polarized, and so on. White light or visible light we see from the sun and other sources like our electric bulbs are mostly used to represent electromagnetic waves because it is the only kind of electromagnetic wave humans can see. Electromagnetic waves travel at different frequencies and wavelengths. This leads to a classification of electromagnetic waves. There are 7 types of electromagnetic waves, and we shall look at all 7 in our lesson on the types of electromagnetic waves. But before we go, let us look at a summary of what we learned in this lesson. In this lesson, we learned that electromagnetic waves are waves that result from a combined vibration of electric and magnetic fields. We also said electromagnetic waves can travel both in space and in other material media like air, water, and glass. We also said electromagnetic waves are transverse waves because they vibrate perpendicular to the direction of motion of the wave. Electromagnetic waves also travel with the speed of light in a vacuum. So keep studying and see you soon.